All right. Good evening, everyone. It's a pleasure to have Jianshu from AI Singapore. For those who don't know AI Singapore, it's a government-led institution, and they are mainly focused on enhancing the AI and the research capabilities in Singapore. But rather than me speak about it, let me introduce Jianshu, and he will talk a lot more about what AI Singapore is and what are the cool stuff that they are working on.
All right. Okay. Thanks, Azu. Yeah. Thanks. It's really our honor to be here. And today with me we have two more colleagues, Mark and Maurice, with us. Yeah. So we are from AI Singapore. We have the team doing federated learning, and that will be the main topic I'll sharing today. Right. So let me share my screen. All right. Yeah. Let me know when you can see the screen. Right. Okay. Right. So yeah. So before I start, right. So maybe I'll just give a quick introduction of AI Singapore, right? So AI Singapore, as I mentioned, it's a kind of a government agency set up by government, right? So the main charter is really to promote more the AI research, and also they are not just about research. You're also talking about the adaptation of the AI in the local industry, right? So the main goal is really to build the ecosystem in Singapore, right? So I think the main stakeholders of the AI Singapore is including agency like NRF, IMDA, EDB, IHES, and SNGGO and SG Innovate, right? So this on one hand. On the other hand, we also work quite closely with the local research community, including those universities and research institutes, right? Like A-Star and NUS, NTU, and the other few universities, right? So we really bring the research and academia industry together to really create the ecosystem, right? So a bit of a little bit more information about AI Singapore. So within AI Singapore, we have three pillars. The first two pillars we have is AI research and AI technology. So we really fund the research. I mean, of course, for AI research, we fund the more strategic activities, right? We give out research grants to universities and also to the companies, right? And also for AI technology, we are organized by kind of themes, right? So I think probably the previous things around healthcare, but the recent one is probably the next one to come out will be around education, right? So those are basically we are trying to work with the bigger research community to tackle more sophisticated and more challenging problems. But Mark, Maurice, and myself, we are from a pillar called AI Innovation and Maker Space, right? So our pillar is really given a mandate by the government to help the local industry to really adopt AI more, right? So that's why we have a lot of collaborations with the local industry. Right, so I mean one of the key flagship program is something called 100 experiments, right? So we work with the company, I mean with some companies we call a sponsor, right, to work together to help them to address their AI problem statements, right? Then we also built something we call the AI bricks. So basically like pre-built AI solutions. Then we're hoping that those solutions can help them to for them to easier for them to start the AI journey, right? So that is about the technology build part. But at the same time, it's not just about technology, and it's not about the blue sky research. At the end of the day, it's also about the people, right? So another big activity AI Singapore is undertaking is really to educate the whole population. So that's why we had a lot of different kind of programs, and the key program and the flagship program is something we call it the AI apprenticeship program. So later we're going to have a few more slides talking about the AI AP. The new batch application is coming up, right? So, and we also have other programs like AI for industry and AI for everyone, AI for student, and AI for kids. Those are something like short courses, right? So in the pre-COVID era, we sometimes we do it offline, face-to-face mode. But of course now because of COVID-19, we move a lot of things to online, right? So those are basically curated contents which for different level of the needs. Let's say for AI everyone, recently we rolled out a multilingual version. It's really for the general public to know what is AI, because nowadays AI is really, we find a lot of applications in our daily life, right? So it really makes sense for the general population to know what AI really means for their life, right? So that was what, I mean, in general, what AI Singapore is trying to do. And just now we talk about the AIAP, right? So just information. So the new batch of the AIAP application is coming up soon. So this time is our batch 8, right? So usually our program is about 2 months plus 7. 2 months is, we call it a deep skilling, right? So we have a lot of curated content to help our apprentice to learn the necessary skills, software engineering and also machine learning soft skills, to equip them the necessary skills to solve the real world problems. And then the subsequent 7 months is really for the apprentice to work with our full-time engineers to really work on those projects, right? So just now I mentioned about 100 experiments. 100 experiments is one of the key things the apprentices will work with us together to deliver, right? And besides 100 experiment, we also have a few more programs, including the federated learning we're going to go through later. It's also like creating new venues for our apprentices to learn the more cutting edge AI technologies, right? And then the program is kind of fully sponsored by the government. Right? So, and then I think on this Friday we have kind of a webinar, a bit like a roadshow, like, to talk about the program. So if you're interested, you can scan the QR code and then log on, or maybe log on to the URL. And some colleagues from AI Singapore will basically go through, what is really this program about, and answer some of the questions you might have, right? Okay, so those are just a bit of a quick intro about AI Singapore and then some of our key programs, right? So without further ado, I will maybe go into the main content of today. It is about federated learning, right? And then as I mentioned earlier on, today with me, we have Mark and Maurice, right? So, three of us are the key members of the team who's working on a project around federated learning, which is also the main topic of today's sharing. And give me a second. The room might be a little bit dark. I probably just need to turn on my the light in my room. Just give me a second. Sorry about that. Right. Okay. So let's start a little bit about the problem in machine learning, right? So I think we all know machine learning. We need a lot of data, right? The more data we have, and usually the model performance will get better, right? That's a general observation, right? Of course, there will be sometimes depends on what kind of a problem you're dealing with. The more data may not help, but generally, right, bigger the data set, usually you have a bit better performance, right? So of course, if you just look at one particular organization, assuming you're just one single organization, let's say you're a bank, you're trying to build a anti-money laundering model, right? If you just look at your own transactional data, you may not be able to build a very generalized model, right? Because your data, you only see your own data. You don't really see other people's interaction with other banks or other transactions, right? So it would be better if we can pull all the banking industry data into one location and aggregate all the data and try to build it, right? And that is probably also a common approach we are building a model nowadays, right? So we try to aggregate the data and pull all the data into a centralized location and build a model, right? That's quite a typical approach, right? But on the other hand, yes, data has machine learning has a very big needs for the data. But on the other hand, I think nowadays our society is certainly getting more and more privacy aware, right? So I think in near to our home in Singapore, we have PDPA, and maybe at a global scale, in Europe, we have GDPR, right? So those are kind of a data regulation. Sometimes they will restrict the usage of data, right? And the usage of personal data, to be more specific, right? And then basically, if you want to share your data with others, you need to make sure that the other party will have adequate safeguard of your data, right? So certainly there will be a bit of the data privacy concern when it comes to sharing, right? But even if, let's say, privacy is not a concern, a lot of times there will be business considerations that will stop you from sharing data, right? Because a lot of times we feel data is really a strategic asset, right? So why do I need to share my data with you, right? Let me know what you want to do with my data, right? So those are some concerns. And there will also be another concern sometimes from technical point of view as well, right? Because sometimes your data might be too big, and the transfer cost from one party to another, it might just be too big, right? So you don't really want to share because simply your data is too big, right? So those are a few considerations sometimes may not make the data sharing or data exchange or data transfer so straightforward, right? So we thought about it and just see, okay, do we have a kind of a means to still build the model, but without violating the data privacy concern, or without the needs for really to share the data, right? For whatever reasons, right? So the answer I think we found is something called federated learning, right? So the key idea is, in a way, in fact, is quite straightforward, right? Because I think we all know at the end of the day, machine learning nowadays is a lot of algorithms. You're basically trying to solve the problem by using gradient descent, right? So to large extent, what we really need, we don't really need to have access to the raw data, right? What we really need is how much I need to adjust my gradient, right? What's the direction of the adjustment and how much I need to adjust, right? So I think we can leverage on that point and try to use a mechanism to share the model or to share the intermediary results, which is the gradient and loss, right? To help me to build a model instead of sharing the data directly, right? So that was kind of the key principle of federated learning, right? So let's use some illustration to see how federated learning really works, right? So assuming there's a group of parties, so those people have data, we call it local data, right? So they form a kind of agreement with saying, oh, let's go and form a kind of a collaboration or a network to build a model, right? But for example, the AML model I mentioned earlier on, right? So instead of pulling all the data together, I mean, that's a more conventional way, right? So you pull all the data together and build it. But now we don't do it. So now we kind of have a so-called a trusted third party, right? So let's trusted third party as a way act as a coordinator. So his role is a bit like trying to coordinate all the training process, right? But he does not really contribute data, right? The only role of this trusted third party is really to contribute the facilitation. We try to facilitate the computation to know like when I should stop, right? So as simple as that. So this TTP, right? I mean, of course, you need to do all the necessary setups. After do the setup, he will send the model. So agree of saying, okay, now I want to build a let's say as simple as a logistic regression model, right? So he will send this model definition to all the other parties, right? And those parties, upon receiving the model definition, they will try to build the model by using their local data, right? So basically, they will, okay, let's say logistic regression. They will all try to build a logistic regression with their local data, right? And then periodically, they will try to send the learnings, right? So basically, it will be the gradients and loss and the weights to the TTP, right? But we don't really exchange the local data, right? So local data in a way is still keep in their pockets, right? We don't really take out the data and share with any other party, right? So even a target third party doesn't really see the data. You only get those intermediary results, gradient and loss, right? And weights as well. Now, the target third party will have all the updates from all those parties, right? And then he will do aggregation. Of course, later we'll go into the some approach with doing aggregation, right? So he will try to do the aggregation of the learnings or the model parameters which he received, right? And then now this TTP or target third party has the aggregated model. And what he's gonna do in the next iteration is he's gonna send this aggregated model out back to the local parties, right? And then those local parties will again will do the training on local data again, right? And then this process will continue, iteratively will continue, right? Until eventually the global model converges, right? So this is in a way hope. I mean, I use some illustration to give the audience here a bit of understanding that how federated learning really works, right? So you can see over here, there's no local data has ever left the premise of different local parties, right? So even the trusted third party will not have the raw data, right? What has been exchanged is only the intermediary results. Right? So this is a kind of a in a very I mean nutshell, I mean how federated learning really works, right? It's a bit like a federated learning 101, right? So yeah, I mean certainly there will be a lot of it sounds simple, right? I mean, I just need to exchange the gradients, right? But I mean, there will be a lot of engineering and a lot of technical challenges we need to solve, right? I mean, probably the biggest one is the data at the moment. Previously, typically, I mean, we'll assume all the data is coming from the same distribution. The key assumption in machine learning is something we call the IID, right? And independent identical distribution, right? But in federated learning, I think the assumption may not hold anymore, right? Because different party may have a different process to generate that data, right? There's a bit of a so-called the heterogeneity in that data. So how are we go about and address the issue is something that's quite important in federated learning, because the implication is sometimes your model might not converge, or rather your model might converge slowly, right? So it's a key thing in there is really like try to do aggregation, how you really do the aggregation to make sure that your model can really converge, right? That's a big topic in there. Of course, there will be also other impacts, more engineering wise, right? So later, I mean, we will have a bit of a sharing along that line as well, right? So certainly it's very exciting. I mean, the vision is certainly very exciting, right? You don't really need to share data, but you can still build a model. So what can be more exciting if, I mean, we choose to be part of it, right? So if you really see the vision, why not you be part of the thing to really build a vision together, right? So that's our thinking around that. So we have kind of AI Singapore to put out a team trying to build a platform, something we call the Synergos, right? And trying to make federated learning is really easier and more user friendly. So what we're trying to do is we're trying to build a platform to hide all those details, right? And then the users of the platform, you just need to do some simple configuration of the model which they want to build, and then they should be able to fire up the federated training. Right? That was what we hope for. So yeah. So later, I mean, we'll spend a couple of minutes to explain what is our thinking behind different components, and what is our challenges in, I mean, what is our journey in solving some of the challenges, engineering and technical challenges, and what is our plan moving forward, right? So yeah, so this is a kind of a what do you call it, the component view of Synergos, right? So as mentioned earlier on, I think the Synergos really aim to make federated learning easier and more friendly, right? So there's a different component. Certainly, it's not just about one component. I mean, early on, we have a kind of a federated learning 101, right? So that's certainly a very simplified view of what is happening. So engineering-wise, we need to build a system to really support that. So this is the kind of different components we have in the system. But this view may not be the ideal view to really see how the system really like what it really means for a system, right? So probably this view will help us to have a better understanding of what we are doing over here, right? So there's a couple of components, and the key components over here, it is something we call it a federation, right? So later we don't have time to go through all the components, but we'll probably zoom in later for the federation components, right? So federation is where the federated training was happening, right? The one we earlier on we have seen it, right? So federation is where the federated training is really happening, right? How the different parties come together and try to train a model in a collaborative way, or a federated kind of manner, right? And we are building our components based on technology called PySIF, right? And some of us may heard about it. It's kind of an open source technology, but it is a bit like a TensorFlow, right? You need to do a lot of wirelings to really make it working. So what this federation component is really trying to do is we help you to do those heavy lifting, right? But what we expose to the user is really just a very easily usable kind of interface, right? So later we'll probably see a demo as well. And there's also some concept we call it a grid, right? Because it's not just one party; it's multiple party involved, right? So certainly different parties need to come together and try to form something we call it a grid, and within basically all the computations, all the coordinates happen within the grid itself, right? And yeah, so that is the key components, right? And then of course we also try you need to support different kind of a compute and storage, right? Because sometimes your data is just simply too big, right? So you might want to, let's say, you might already have invest in your IT infrastructure to have a Spark or maybe Hadoop in place, right? So we need to support that as well. And sometimes you might use storage, different kind of storage backend, like S3 or maybe some other storage systems, right? So those are the things which you need to support, so that you can do all the heavy lifting for during the federated training, right? So this is something that we call it like federated learning made simple, right? So you just need to do some easy configurations, and then you're able to fire up the training to build a federated learning model, right? And then you move on to the next layer is really something we call it like FL ops made simple, right? So nowadays we talk about ML ops, right? It's really about model management and model serving, and also the a bit of auto ML as well, right? How do we really do the hyperparameter tuning and things like that, right? Because at the end of the day, I think machine learning, a large part of it is really about how you really tune the parameter, right? So those are the second layer of kind of functions which we build in place to really make the federated learning ops simple, right? So we have the model lifecycle management, we have the orchestration, we have the model serving. So we are kind of integrating with different kind of tools, right? Things like ML flow and things like a ray tune. So those are the things we are trying to building and to make the federated learning training, especially hyperparameter tuning, much better, right? And then on the model serving, there's one thing which maybe I want to highlight is typically when we talk about model serving, right? So in the typical ways is that maybe we get a model and then we'll try to expose as a kind of a REST API for the users to consume, right? But in that case, it's like the user or the consumer of your model, they still need to kind of pass the data to the one with the hosting the model, right? So we thought about it. There should be a better way to protect the privacy as well, right? So we make an arrangement is like whoever want to use the model, the user might not be the one who contributing data to train the model, right? But you might want to consume the model. So we make a kind of a design is like if you want to use the model, you should also join the grid, because earlier on I mentioned the grid is where the training happens. So different parties come together and build the model, right? So for the model serving, we make a design is like for other people, for the new users who want to kind of use the model, right? So they need to download the Docker images, and after they download and join the grid, the model will be pushed to them, and they don't really need to send the data out, right? So they can also do the inference locally as well. So in a way, we feel that is a better protection of the data, even during the inference stage, right? So this is something that in the middle layer, there's something that around the model management, right? And the goal is really to make the FL ops simple, right? And the last layer is really on the platform management. It's really about metadata management or dashboard, right? Because different party, they may not share data to others, right? But you still need to let others know what data you really bring on the table for other people to use, right? So there should be sharing of the metadata. You need to let other people know that what kind of feature you have, right? And what is the meaning of the feature, so that they will know, okay, whether your data are going to be useful or not, right? Because we want to prevent the scenarios, because the benefit, to a certain extent, federated learning a bit like a double-edged sword, right? Because the benefit is that you don't really need to share your data, right? But on the other hand, it's like, okay, now your collaborators, your partners don't really you don't really see other people's data, right? To one extreme is like some malicious guy can even purposely bring some dummy data or just lousy data to really pollute your model, right? It can happen. So a bit like the old P2P era. A lot of people also try to be the free rider. They just go and download. They never share, right? So we saw, okay, if this things happen again for the federated learning, and federated learning may not be sustainable, right? So I think there should be a need for other people to tell others what data you have, right? That's one thing. Another thing is that there is always a need for us to fairly calculate the contribution of different parties, right? You want to make it sustainable, right? So in a way, why do I want to share my data to other people? Of course, I want to gain something in return, right? If I can gain something, of course, make it more meaningful for me to share data for other people, to contribute data for other people to use, right? So we feel the contribution and reward is a key things to really make federated learning more sustainable, right? So we put quite a substantial amount of effort into building the components, right? Now, of course, on top of that, there will be a kind of dashboard. You try to see all the different kind of information generated throughout the whole process, right? So this is kind of the key components of the Synergos, something that which we are currently building, right? And of course, it is not just about building a system. At the end of the day, we would like the industry and the community to use it, right? Because we're not just doing it as a kind of engineering exercise. We really hope this is something that at least Singapore community can benefit as well, right? So we are also like quite actively trying to find a use case of Synergos and try to see what benefit we can bring to the community and to the industry as well, right? So I think we so far we have been trying to find applications of Synergos. On the one side, we're building the platforms, right? But on the other hand, we're trying to find useful applications, meaningful applications of what federated learning can help and what Synergos can really help, right? And theoretically speaking, the platform can be applied in any scenario which, in a way, something we call it horizontal federated learning, right? So as long as there's a different party, they have a big overlap in terms of the attributes and the feature space, right? And then maybe they have a small overlap in terms of the object space. For this kind of scenario, the platform can play a role, can contribute, right? So this is something we call it a horizontal, because the data in a way is kind of a split horizontally, right? Because it's split by different kind of people's kind of data object space. So meaning, assuming again, we talk about the AML example earlier on, right? So assuming every party corresponding to different banks, right? So different bank, you might have a different kind of customers, right? So over here you can see that the ID basically represent different customers, right? So over here you can see different party, they have they see different users, but in terms of the feature, right, in terms of the attributes, they're more or less seeing the same set of features, right? So for this kind of a scenario, I think the system we can already support it now, right? And a quick example is later we're going to go slightly into more detail, right? But certainly the one that which you mentioned about the AML can be one example to which the horizontal or federated learning can play a role, right? So there might be a question. Okay, since we talk about horizontal, is there something they call a vertical federated learning? The answer is yes. So later we also will spend a little bit of time going into that, right? So that one is something that which the Synergos is going to support as well. But at the moment, we will focus on horizontal. I mean, today's sharing, we're going to focus on horizontal. Right? And yeah, so this is a kind of an example, the AML example, which we shared earlier on, right? So the banks doesn't really need to share the data, right? So they can use the local model to build the so-called the private version of the AML model, but they can exchange the weights or the immediately results with other parties, so that then with the trusted third party, and the trusted third party can do all the applications to build the global model, right? So that the model can be more generalizable for the whole industry, right? And there's probably the second use. I mean, later we're going to spend a little bit of time into go into a little bit more detail into another use case, which is something we did for the healthcare industry, right? Because healthcare, a lot of times, probably have the same issue. And healthcare probably have even a more serious problem there, because healthcare, especially hospitals, they have a stricter privacy kind of regulations, right? So you can't really share the patient's data because it's really like sensitive, right? But even if you say in the GDPR kind of lingo, it's considered a special category of your private data, right? So you can't really share the data just like that, right? So if you want to build the model for healthcare, sometimes it's that if you just look at individual healthcare settings, right, the data may not be sufficient, right? So there'll always be a need. We're trying to pull all different hospitals' data together and try to build a model, right? So certainly healthcare will be probably another industry which can benefit a lot from the federated learning, right? So we recently do a kind of a pilot, right? So what we are trying to do is we're trying to build a model for the mortality prediction for the ICUs, right? So ICU is kind of I think we all know about ICU, right? So it's really like a very time sensitive kind of a ward in the hospital, right? Because typically the patient being admitted into ICU, usually they are very critically ill, right? So the doctor need to make a decision very fast, right? Because the resource is also very, very scarce, right? And then I mean, the doctor really need to make a decision very fast in terms of the because your patient's kind of a life will depend on you, right? And then there's also usually, I mean, the resource in ICU is also limited as well, right? So it's always a kind of a balance. You need to really make a decision very fast, right? So that's why typically I think a kind of a scoring system in ICU will really help the doctor a lot in terms of making decisions, right? So there's something called Apache 4, right? So basically you just need to key in when a patient being admitted into ICU. So you need to kind of figure out kind of a scoring, right? This score basically will tell how severe the patient is, right? Of course, the more severe patient, you will put more attention to it, right? You need to put more resource into the treatment of that particular patient, right? So typically you need to key in all the different kind of vitals and some of the measurement or the testings, right? And then it will give you a score, right? So this one will be very helpful for the doctor, right? But as we mentioned earlier on, currently a lot of times the hospital, they probably can't really share their data, right? Privacy concerns, different concerns. You probably can't really do that. And then a lot of times you build the model internally, right, by using so-called a single sensor kind of approach instead of a multi-sensor. But multi-sensor certainly will have a lot more benefit because you can see more patients and the model will be more generalizable, right? But because of the data sharing constraints, you may not be able to share data and then build a model kind of on a whole, a bit difficult, right? Whole industry is a bit difficult. So we thought, okay, federated learning can be really a good fit for this kind of scenarios. So that's why we kind of apply our platform and try to do some kind of a pilot, right? So we try to use federated learning to build a model to predict the mortality for the ICU, right? So in that case, we are using a public data set which is called EICU, and this is a kind of a data which is collected in the US by Philips, right? So a lot of hospitals buy devices from Philips, right? So those like hospitals which they buy Philips. I mean there's a team, I mean MIT, to really collect all the data and then make it available for the whole community to really use the data, which is certainly very useful data source, right? So the data and there's a different hospitals, right? I think it was over about 170 hospitals in there, right? Of course, for this particular pilots, we didn't use all of them. We do some cleaning and then we do some data selection, right? So because there will be some patients, it's not really like for some reason it's not really staying not ICU stays, right? And then there are also some data which they don't really have the Apache 4 scores. Those are we all like filtered, right? So all in all, after do all the necessary filterings, and then it leaves us about 40 something hospitals, right? And then at the end of the day, we choose the top 20 hospitals with the highest number of ICU stays in this particular pilot, right? And what we're trying to do is simple. It's trying to predict the mortality. So basically, the target variable is whether they die in hospital or not, right? And then the features basically are those readings, right? So I think in total we have about 90 features, 80 or 90 features, right? So this is kind of the data. And then in terms of the model, because of the high explainability requirement, right? So the model we built is logistic regression, right? Because if you go back to the earlier on, the Apache 4 kind of score, it's basically some form of a generalized linear model, right? Basically a logistic regression model. So I think this is kind of the model we built, right? So and then I mean we kind of by using the Synergos to train a model, right? So later, Mark, I mean another colleague of mine will give you probably a deeper view of how the Synergos can be really used, right? But over here, I just trying to list a couple of the screen capture to show that how easily the Synergos can really be used, right? So there will be a few steps you need to follow. I mean, initially you need to register, right? Okay, now I'm built this over here. At least kind of a hierarchy, right? So for each of the so-called the project, you need to. There's a concept called project. Project is basically for this particular case is basically like I'm trying to build a model to predict the ICU mortality, right? And then under project, there will be a concept called experiments, right? So experiments in this case will be under this particular project, I'm going to build a model, and this model is a logistic regression model, because you might have another set of experiments to build other models. Let's say, for example, you want to build a tree-based model, for example, right? So those are basically the concept of experiments. And then under the experiments, you might have multiple runs, right? So each run will basically corresponding to one set of parameter, right? So let's say you might use different, for logistic regression, you might want to use different regularization terms, right? You might choose different lambda, and then you might also like use a different learning rate, right? So those different set of hyperparameter will basically corresponding to different runs, right? So this is kind of a hierarchy which Synergos define, right? So before we doing the real training, we need to define the structure over here. You need you need to define the project. So over here you can see, okay, I'm doing a project. Project ID, of course, you can choose a project ID, right? And then the action is classified. Of course, you're doing regression, then you just use the regression, regress, right? So over here you're declaring, okay, I'm going to build a model, classification model, right? And then within the on this project, I'm going to build some kind of define some kind of a models, right? Over here, let's say, assuming I'm going to build a logistic regression model, right? So over here, you just need to kind of define, simply you just need to define the network architecture which you are going to use. So over here, it's just kind of a quite simple, just one layer kind of network, but you just need to define the experiments which you are going to use, right? And then again, you also like define the runs. Right? So over here, you can see all the different kind of hyperparameters you just need to specify over there. Right? So how many runs, how many local epoch, and what is your learning rate, and what is your kind of the lambda value, right? So those are things which you specify in the runs, right? So after you define that, you just need to define, okay, because different people, there are different parties, or in this case, different hospitals, right? They need to register the data, right? But again, you just register, right? You don't really need to share the data. You just need to let the coordinator know, okay, this is the data which I'm contributing, right? And this is and then the basically you also need to set up the connections. What are the ports which you use to communicate with the TTP, right? And that's it, right? And then that's it. You just need to do those simple steps. And then next will be start to do the training, right? Of course, there will be another step which is called alignment. Later, we're going to go into what really alignment really means, right? That is also in a way, it is also part of the problem of the heterogeneity of the data. Right? Later, I think Mark will spend a bit more time into that. So after you do the alignment, so now you're really ready to do the training, right? So you just need to we'll say, okay, now I want to create a model, right? So this model will create by using those declarations which you made earlier on, right? I'm going to train this project, this experiment, this particular runs, right? And after that, the system, the Synergos will do the heavy lifting on the background, and you just need to wait. Of course, typically it will take longer time, and communication costs will be higher because there's a lot of back and forth communication between the local party and the global TTP, right? But other than that, you just need to wait, right? And then after you train, and then you collect all the information and do the then you get a model, right? Of course, for this particular exercise, we need to collect all the information and try to compare. One thing you want to compare is how does federated learning compare with a scenario which purely local training, right? You don't really use any other hospital's data. And also we try to compare with another scenario is like now I'm trying to pull all the data together and build a model in a traditional manner, right? Basically doing all the centralized training, right? So two key observations over here. I mean, the charts, like colorful charts, right? But basically the two observation is if you compare federated learning to training by using only the hospital, the local data, right? Only the data from one particular hospital. Federated learning will constantly show improvement, right? It will constantly show improvement. But if you compare federated learning with the centralized training, right? The performance, I mean, in this particular case, the performance, in fact, it is not, you don't really see a big difference, right? But there's an additional benefit is that you don't really need to exchange your data, right? So meaning even now I don't really exchange data, but I can still build a model with the similar level of performance which centralized training can achieve, right? So that basically shows that, okay, in fact, to a certain extent, federated learning can achieve the same level of performance, but at the same time, it will give us additional benefit of you don't really need to share your data, right? So that is additional benefit. And over here, you can see there's something called Fed average and the Fed prox. Right? So later we're gonna come to it. That is a two specific approach when we come to doing the federated aggregation, right? Earlier on we talk about there's a local model you need to send to TDP and do the aggregation. Right? So these are two specific approach which so far I think the Synergos has been able to support, right? So this is basically I mean what we have done so far. I mean in a high level, right? So we basically we have built a platform to support federated learning, and we also have been trying applying the platform in various different kind of use cases, and it also shows that okay, in fact, federated learning, you will achieve the same level of performance compared to what the centralized learning is doing, but at the same time, it takes away the other needs to exchange the data. But that is an additional benefit, right? You don't really lose in terms of the accuracy, but it give you additional benefit of you don't need to share the data, right? So this is a kind of on a high level. I mean, what we have achieved so far. Of course, there will be a lot of things under the hood, right? So I will probably pass to Mark, and Mark probably will walk us through like some of the design of the key component, which is called the federation. Right? So federation is really, if you still recall, it is really the key components where the federal training is really happening. Right? Do the different party that come together and train the model. Right. So maybe before Mark, I pass it on to Mark. Any immediate feedback or immediate comments? Later, we're going to have a Q&A as well, but maybe just take a pause in case there's any immediate question. Nope.
Hi, JS. There's actually a question in the chat.
Okay. All right. Okay.
Yeah,
give me a second. Let me go to the.
Yeah, someone is asking, does Synergos support federated transfer learning as well?
Okay, that's a good question. So far, not yet. Yeah, thanks for raising it up. Yeah, this is certainly something. There's a lot of research actually going on as well. But the quick answer is not yet. But it is certainly something where the team is going to look into as well. Yep. Thanks. If not, yeah, later we're gonna have another probably a couple of minutes for Q&A. But maybe I'll pass it over to Mark. Mark will walk us through the federation component. Mark.
Hi, thanks. Let me take over the screen first.
Right.
Okay. Yep, very good. Okay, so my goal here for the next section is to talk to you guys about what the federation component actually truly entails, right? So just gave a brief summary of what it actually means just now. Okay, generally we are actually encapsulating all the complexity, and we're trying to resolve it into few steps. Okay, three main phases. Okay, and as you'll see later on, the three main phases constitute a total of 9 steps, 9 single line commands. So the entire complexity of federated learning has been decomposed down into just these 9 steps. And yeah, I hope that you'll see value in it. Okay. So the first things first, okay, our system is a duet of 2 containers, meaning that there are 2 different components that you download, as mentioned by JS just now. Okay, one component is the TTP component, and the other one is the worker component. So whoever who is participating in the system will download the necessary component that is according to their role that they want to participate in, right? So if you are a person that wants to that has data to contribute, you guys will download the worker node. If you guys are the orchestrator, okay, you're the TTP. TTP means trusted third party, whereby you are the one assembling the model. In a remote setting, you'll be downloading something called the TTP container. Okay, and how people So in this setup, what happens is that you won't, no party will have access to any of the raw data sets, okay, the owner itself. Okay, so the system allows us to mount our own data sets within our own containers, okay, and it orchestrates everything very naturally. Okay, so let's go into more detail. Okay, so there are a total of 3 phases. Okay, the first phase is after we have launched our necessary components. Okay, we are actually going to do phase 1, which is registration. Okay, registration refers to you submitting your metadata, okay, with respects to how you actually connect. For the trusted third party, he is actually submitting the project status, the model that you want to actually train on, the model architecture, the hyperparameter tuning, okay, the hyperparameters that you want to actually train the model on. Whereas the responsibility of the worker during registration is to submit their connection information so that the trusted third party can actually complete the grid and actually proceed onwards. Okay, so the second part, okay, once you have actually set up the entire grid, okay, the grid is now live. Okay, so this is where phase 2 comes into play, the most important phase that everybody is interested in, okay, the training of the actual model. So what happens is that, like what JS mentioned just now, this is where we clone the global model, distribute it out to the workers. The workers will train the global model, the clone local models, the clone global models, which are now locally, that exist locally on each worker. They'll train it, get the local weights, okay, and then return it back to the trusted third party for aggregation, okay, to update the global model. And this is done iteratively in terms of rounds. Okay, once this is done, okay, we end up with the final phase, which is the evaluation phase. So the evaluation phase is where, okay, now that the global model has been trained, the next step is to actually check its use, right? So this phase comprises of things like validation and inference. Okay, where the trained global model is actually sent out, okay, to the parties that are requesting to use it, okay, and the model interacts with the parties' data, okay, and gives the participant their predictions and statistics. Okay, after that, then the model gets returned to the TTP. So at no point is there any violation of any price, because the raw data set never actually leaves the server. Okay. So in more detail, right, this is actually the things that will actually be happening. Okay, so right here you see that there are quite a few things. There are quite a few things to look at, right? But the essential, the fundamental thing about our system is that it hides all this complexity over here, okay, with an abstraction layer. So the admin person who is actually, which is most likely your data scientist, is actually interacting with the driver interface, okay? And through the use of the driver interface, what happens is that all these necessary substeps will be triggered within the TTP node, okay? And these triggers actually populate the backend cache, okay? And it will automatically set up, right, an internal grid that actually helps to kick off the training. Okay, so everything occurs seamlessly. Okay, you submit all your different metadata, and once done, okay, once training is being triggered, all the orchestration will occur over at this point, and then the model is stored back for later use. Okay, so now let me show you what it really means to do this. Okay, so over here, okay, and I've color coded the terminals. Okay, so over here, this is the, okay, on the right hand side you'll see 3 workers. Okay, and on the left hand side we are seeing something called the TTP, which is our main orchestrator. So like I mentioned just now, all you have to do is actually download our component and run it. Okay, so this is what I'm going to do. I'm going to run, okay, each worker. Now each terminal represents a remote server. It's actually connecting to a remote server. Yeah, okay, and let me launch this. Okay, and just like that, we have set up the grid. Okay, we have set up this grid. Okay, that's quite simple, right? So once you have done with this grid, right, this is where your data scientist can start doing the necessary work. Okay, so over here, okay, I have this Jupyter notebook. Okay, how we actually go about doing this, okay, is in 9 steps. Okay, so we have gone through the startup phase. Okay, the next step is for us to actually just use our driver interface. So our driver interface is what we mean by this component over here. Okay, so the driver interface, okay, is one line, okay, over here. So let me run our driver interface. Okay, and now we are connected to the grid. Okay, so the next step is for us to submit our project. So over here, okay, this is the initial state. Let me submit the project first. Okay, so now I'm emulating the role of a TTP. Okay, remember the TTP needs to submit a project, an experiment that consists of the model architecture that we want to test on, and then the final one is the hyperparameter set that we want to work on. Okay, so let me submit this. Okay, so over here, as you can see, I've submitted my project. Okay, and this reflects it over here, as you can see over here. Okay, so let me complete the submission process for TTP. The TTP submits a logistic regression model over here. So let me submit this. Okay, as you can see, the logistic regression model has been submitted. And finally, we submit the training run. So over here, in the interest of time, I'm doing a very small set of runs. Okay, and let me submit this as well. Okay, so with this, the TTP's role in terms of the registration phase is complete. As you can see, the changes have been registered. Okay, so the next step is for the participants to register their connection information. Okay, so over here, we have a total of 3 participants, worker 1, worker 2, and worker 3. Okay, and so this is what happens. Okay, we are actually submitting our connection information to the TTP and saying that, okay, our components are up. Please, if you need to create the federated grid, please use it. Please use them. Okay, so let me submit this. Okay, so over here you see we have actually successfully registered each participant: participant 1, participant 2, and participant 3. Okay. Oh, and before I forget, this currently this data set that we're actually doing the experiment on is reflective of a kind of a real world situation. It's a heart disease data set. Okay, there's open source. In just the background is that there are actually 4 databases where there are from Cleveland, Hungary, Switzerland, and VA Long Beach. So what we're actually doing is a federated setup of this data set. Okay, so let me go back here. So once the participant has registered, the next step is for them to register what is their role and which project that they want to actually participate in. So over here, they are registering for the project, in this case called the heart disease project. And guest and host are arbitrary terms that actually means that if you're the host, you're predominantly there to contribute your data. If you're the guest, you're more of interested in interacting with the model. But anybody can be a guest, anybody can be a host. Okay, so let me submit this registration step. Okay, and you can, as you can see, okay, participant 1 has been registered to heart disease. Okay, same for participant 2 and participant 3. Okay, so the final step, okay, is now that we have actually registered for our setup, right, for a particular project, the next step is to actually submit which data sets do we want to actually use. Okay, so over here, we are actually submitting all the different data tags that we want to use. Okay, so let me run this. Okay, and as you can see, okay, heart disease 1 project, we have submitted train and evaluation sets. Okay, and this has happened for each participant. Okay, so that is the longest phase of all. Okay, so that's the registration phase. But once we are done with the registration phase, that's the easy part. Okay, the next few parts is it comes as you can see it's just 4 commands. Okay, so the first part is what we are calling alignment. Alignment means that we have to align the state of every single component within the grid. Okay, why we want to do that later on, I'll go into more detail, because when you have when in a federated system, you don't have access to analysis or EDAs, so there will be some deviations in terms of the data sets. Okay, and this is a natural occurrence when you have heterogeneous data sets. Okay, so over here I'm going to run alignment. Okay, alignment will help me align all components within the system. So over here we have 4. So let me run alignment. As you can see, alignment starts and it was fast and it finishes. Okay, so over here alignment is completed. Okay, and we have seen that all the data sets are aligned. Okay, you see over here you have to have an additional index being inserted over on participant 1. Okay, so now all components, all 4 of these components are actually aligned. Aligned meaning they are ready, they are compatible in terms of their data symmetry, they are compatible in terms of their model architecture as well. Okay, so the next step is finally the meat and potatoes of what we want to do. Okay, over here we are going to commence training. So again, it's one line. Let me commence training, and this is what it looks like. Okay. So over here, what you see is the global model being updated, as well as you see all this stream of content over here, right? What this is actually something called computational operations that is being sent over. So at no point of time is any raw data being accessed, but rather operations like, okay, I want to multiply your matrix by 10, right? So you send the operation over and say multiply by 10. Right, so the operations are being sent over, but the data does not actually leave the system of the server, and this is very important because this means that federated the privacy component of federated learning is not violated. Okay, so over here, as you can see, okay, it was a fast one. We are done. Okay, so over here, see, okay, we have trained our model. Okay, and over here we have local models all being stored, as well as the global models, the final global model being archived. Okay, and just like that, we have trained our model. Okay, so the next step, okay, is the inference phase. So the inference phase is very simple. Okay, over at the beginning, we actually registered a training set and a validation set. So now we will have to benchmark the performance of our model, right? So what we'll do is we'll take the global model, okay, we'll distribute it and interact it with all the validation sets. And once we send it over, okay, so maybe you can use this diagram. Once we send it over, okay, the statistics will be computed based on the prediction values yielded, and then the worker node will actually store the statistics for their own consumption. Okay, so let's run this. Okay, let's run validation. Okay, so validation is now running. Okay, like this. Yep. Okay, and validation is done. So that was a fast one. So over here, as you can see, okay, yeah. So over here, as you can see, okay, this is only a 2-round, 1 epoch kind of training. So a very short, a very small amount of rounds for demonstration's sake. For demonstration's sake, but as you can see, we have a stratified. The way we record our metrics is in terms of stratification. So over here, we have 5 different classifications of the state of heart disease, and therefore, for classification 1, we have the accuracy of 66%, 47, 66, 88, and 89%, so on and so forth. Okay. So then we have done this for every single validation set registered for each party. So over here, we have done it for participant 1's validation set, for participant 3's validation set, and for participant 2's validation set. Okay. So now we have all the validation statistics. Let's say that we are satisfied with this model's performance. Okay, and so we want to do deployment, right? We want everybody to use this model. So how would you as a participant use it? Very simple. Again, using our driver interface, okay, what you'll do is you'll declare within your own mounted folder, okay, where is your prediction set. So over here, we call our prediction set predict. Okay, we declare it as a new data set, okay, and we specify what is the participant requesting for this inference, okay, and therefore let's run this. Okay, so over here, Okay, this is inference running. And we are done. Okay, so over here you can see, okay, this model that was being trained, okay, what is the performance like on a new set of data, right? So over here we have the performance for participant 1 and their prediction sets. So you can see for certain, this 2 round 1 epoch model has certain features that can capture certain states of heart disease more effectively than others. But with more tuning, that would be better. Okay, so over here we have managed to interact with the participant 1's prediction set, participant, yeah, 2's prediction set, and participant 3's prediction set. Okay, so overall, okay, are the 9 steps. Okay, let me rephrase. There are 3 main phases. Okay, registration, training, and evaluation. Within these 3 phases, all it takes is 9 different lines of code. Okay, and with these 9 lines of code, you are able to train a federated model relatively easily. Okay, yeah. So this is Synergos. Okay, the how and how to use it as part of a federated as part of a federated experiment. Okay, so just now we mentioned something about heterogeneity, right? So what is the meaning of alignment? So alignment semantically means that we are aligning the states of every single component within the grid. Okay, and this means that the different the TTP has to have its model corrected for corrected to be able to match the workers requirements, and the workers own tensors have to be aligned with each other, right? But how do you do this without any knowledge of how do you do this without any knowledge of the data set? Because privacy is the main concern, right? So over here, okay, we have something called feature alignment. Okay, so feature alignment means that feature alignment is required because when you do one-hot encoding, okay, so for example, the heterogeneity of the data sets will make sure that if let's say I have a paint shop, okay, 3 paint shops, each paint shop sells a different set of paints, right? Paint shop A over here sells blue and red, paint shop B sells blue, green, and red, and paint shop C only sells one color, yellow. Okay, but when you do, so this is a categorical variable, right? But when you do one-hot encoding, what happens is that you will have different number of columns, right? And so this is one example of heterogeneity. Okay, when you have different number of columns, what happens is that the model becomes it becomes very difficult to identify what is your input layer for your model. That's one. The difficulty lies on the TTP's end, as well as how do you make sure that you can extract the features from every single component, for every single worker, okay, and make sure that every participant has an aligned data set. Okay, so over here, what we did, okay, was we took a page from bioinformatics. Okay, so in bioinformatics, there's a very important use of sequence alignment, because in DNA is not going into much into the detail, but DNA is a set of of a string with many characters, right? And what happens is that each individual cluster, okay, within that is similar across the DNA strand is actually meaningful to medicine. Okay, when you want to construct a specific protein and medicine for to be compatible, right? Okay, so over here we took inspiration from here. Okay, and so if you look closely, actually the alignment mechanism is similar to our needs, because what we need to do is we need to align the different headers, okay, to make sure that we populate the necessary missing columns. Okay, the necessary missing columns, what I mean is, in this case, right, the necessary missing columns over here. How do we make sure this part is aligned, and how do we make sure that the global model template that we actually declared is actually aligned for our needs? Okay, so this is the general phase of feature alignment. Okay, when I have 3 particular paint shops, okay, what happens is that the TTP will say, okay, please pass me all your headers. Headers are one-hot encoded columns, okay, the names of the one-hot encoded columns. The TTP will collect them all, and then they'll do an alignment process whereby it identifies which columns are missing for each particular worker, okay, and then the TTP sends back to each worker the indexes to populate the missing columns, okay, and this population is via padding or other pre-processing mechanisms, okay. But in terms of, regardless what mechanism we choose, at the end of the day, what happens is that in stage 4, as you can see over here, each tensor that represents the data set within each worker is now having the same structure, okay, and this is good, okay. So that's just a brief intro to what so one aspect of alignment, okay. So the next aspect that I would like to zoom in is something called heterogeneity, being very difficult to prioritize, right? Because who like what Jess mentioned just now, there's cases of data poisoning, there's cases of what happens if a particular worker or a particular participant has a lot of data, but the data is not very clean. It's dirty data confounded with many random variables or variables in a random distribution, right? So over here we have a few algorithms being integrated. One of it is called FedProx. FedProx uses something called a proximal term, okay, that actually extracts gives priorities to a participant's model if the model has a larger change after a local training than it initially was before. They initially did before. So if you have, long story short, if you have made a more significant change in the global model, you will be given more priority in terms of your weight. Okay, of course, this is in itself one aspect of handling this poisoning problem, and we have future algorithms that are coming up. Things like integrating split learning into it, things like scaffold, so on and so forth. Okay, so that's just a few one of the many algorithms that we have incorporated in the system that you don't have to worry about coding it by yourself. Yeah. So to use the FedProx algorithm is simply a declaration of the where is this? It's a declaration of the, yeah, you pretty much declared it in your hyperparameter set. Okay. So yeah. Okay. So now I'll pass the mic back to JS and Maurice, who will introduce to you guys what is the future for Synergos and what we are going to be working on next.
Yep. Yeah. Thanks, Mark. Thanks for the demo and the explanation. Yeah. So yeah, I mean, I can see there are some questions. I mean, there's one question from Ed, but I'm gonna come to it later. I mean, if you can hold on for a while, I'll probably come to the question answering later. And I have a few more slides to finish. I mean, there's many about our roadmap, right? So basically, what to expect for the future version of the Synergos, right? So I mean, just a couple of more slides to finish, and then we'll come to the Q&A. Yep, thanks. So yeah, so just now, I mean, you saw some demos and the kind of a presentation from Mark, right? I mean, in terms of how I mean, under the hood, what we do to make federated learning really like easier to use, right? So I mean, feel free to give us some feedbacks and suggestions. Right? Certainly welcome that, because I think we are starting the journey, right? It's certainly not the end of the journey. It's certainly just a starting of the journey. A lot more few more features gonna come in our pipeline. And as I mentioned earlier on, we're also like trying to apply Synergos in more use cases. Right? So if you have use cases in mind, which you feel that maybe federated learning can be a good application, I mean, feel free to reach out to us as well. Yeah, so it can be any industry, right? It can be finance, energy, or education. So any industry, maybe if you feel there's a need or you see a benefit of applying federated learning, you can let us know, right? So this is a kind of a my slide is not moving. Right. Why is it not moving? Okay, now it's moving. Right. So this is kind of a very quick overview of our roadmap in terms of our development, right? So now we are around like because November 2020, right? So basically last month, we kind of so-called having a preview version, right? So more like an internal preview version, and then of course we also like reach out to a couple of our partners, right, to try out the platform. So in terms of this version of the preview version, I mean for the federation, just now we sort of demo, right? You know, we have the federated components, which is kind of quite ready. So we have the a couple of algorithms already been supported, right? Fed average, Fed prox, and feature alignment, and some pre-processing steps also included as well, right? And then we have been trying the Synergos on building models to analyze data, like tabular data and image data, right? So those are the two main type of data which we have done some testing, right? So what are gonna come next, right? Because the next probably a major milestone will be probably Q2 or Q3 next year, and that will also be a time when we're gonna kind of officially launch Synergos, right? So basically, I mean, our current plan is probably we'll try to make it open source, and then the community is certainly feel free to contribute or maybe kind of clone our repos and use it, right? And then I mean, certainly as part of the kind of a distribution, certainly there will be a lot of examples and documents, which at the moment I think the team has also been working on as well, trying to help our users to really onboard into the system, right? But in terms of feature, we're gonna have a lot more features. I mean, like in terms of for different components, right? For the federation, something that Mark mentioned earlier on, we're gonna support speed learning, and this is gonna be something that we are trying to use speed learning to support both horizontal and vertical learning. Right? So later, gonna a simple slide to talk about what is vertical learning, right? Vertical or federated learning. And things like a scaffold will also be something that we are going to support in next version, right? And then those are the kind of the more how do I put it, the more popular algorithms in terms of federation. Right? I mean, the team itself, we also like doing our own so-called research and try to see whether it will be other more other type of aggregation method which we can come out to for more specific kind of use cases. Right? We're also doing some our own research as well, and those things. I mean, the outcome of research will also be part of our release for the next version. Right? And then in terms of orchestration, I think one key thing will be hyperparameter tuning. Right? I think at the moment, as I mentioned earlier on, we're kind of trying to make the hyperparameter tuning a lot more easier, because I mean, if you look around, there are some other like federated learning platform available out there, right? But a lot of times we don't really touch on the hyperparameter tuning, this particular function. I think this is something that we feel is quite important, because I mean, one thing is because one round of federated training can be quite long, right? I mean, this is our own kind of experience as well, right? I mean, why just now Mark only show a very quick run is because sometimes if you really want a full run, it's gonna take you a couple of hours, right? Because I mean, there's a lot of communication involved. That's why usually it's slower. So you don't really want to sit in there and just wait for to complete it, right? So I think the hyperparameter tuning, auto tuning will really make data scientists' life much easier, right? So this is something that which I think the team has been actively working on. And then there will be model lifecycle management. Just now we talk about ML integration, right? So I mean, how to really manage the different life cycle of your model, right? Let's say after you train a model, you try to promote one model into production. How you're gonna do it? I mean, how we really tie together with the mainstream kind of ML ops kind of tools, right? And the model serving, I mean, the one we mentioned earlier on. We are doing it a bit differently from other platforms, right? Because we felt even during the inference stage, we also want to protect the privacy of the data, right? So I think we kind of make that kind of a design decision. Metadata management, it is also something that the team has been actively working on, and try to, as I mentioned earlier, is really to make the federated learning more sustainable, right? Because you want to really see what other people are really contributing, right? Before you really make a decision whether you want to use the data, right? And then in terms of model, in terms of data, we are going to support next would be sequential data, basically, right? Time series and text data, NLP. Right? So those are the things which we are doing active development. So hopefully Q2 or Q3 next year we can have we can make a public kind of a official launch, right? And then of course longer term, it's not just again next year Q2 or Q3 is not really again not like the end of the journey, right? The journey will certainly continue. And longer term, if you look at longer term, right, one thing which is in our kind of our roadmap is really to support the edge computing, right? But edge computing is probably a totally different ball game, right? It's not just about talking different aggregation strategy, because a lot of times the edge device may not have that kind of same level of compute power. So how you really do the aggregation, how you really like distribute the load is also something to be considered, right? And second thing is deployment, because at the moment Mark mentioned about we basically deploy by using a container, right? We containerize a lot of different components. But if you really want to talk about edge deployment, maybe we need to reduce our footprint, right? So Docker may not be the right approach, right? And then support for more compute and storage backend, things like Spark, things like S3 is also something to be supported. I think we already start working on that already. And another key thing is the contribution and reward, right? So contribution and reward certainly we feel is something that's very critical, and it's going to be a one differentiating factor of our platform as well, right? Because we really want to make federated learning in a way is more sustainable. You don't want to be in the same situation. I mentioned earlier on in the old days, the P2P kind of a era, right? So a lot of people just go take advantage of other people's contribution. They don't really contribute meaningful things, right? So you want to make sure it doesn't really happen, right? But of course, the contribution not necessarily. Maybe it's a bit like a response to Ed's question, right? So the contribution not necessarily be a monetary kind of a reward, right? So there might also be another type of a reward is like if you contribute more data or maybe a better quality of your data, the model, because we might differentiate by the model which you are getting, because at the moment we talk about one global model, but maybe there will be another approach is that, okay, maybe different people are getting a different version of the model. It's not really the global model. Of course, the global model will still be there, right? But at the end of the day, maybe different party will receive a different so-called local copy of the global model, right? So if you contribute more or we contribute better data, to a certain extent, you might get a better version of the local copy of the global model, right? Those are the things which are also looking into. But to be very honest, we haven't really make up our mind, right? What would be a better way to support, right? Maybe it will coexist, or maybe there's something that maybe we build in your system. When you deploy, you need to choose which kind of a reward mechanism you want to go for, right? So a quick answer to your question is, so far we haven't really like think about that yet. In multiple directions we can go, right? But certainly this would be one key component in our system, right? No one's for sure going to be a key point, but just that which direction we're going to go for. I mean, that's probably something we need to think, right? Because to us, contribution and reward is probably is two. I mean, of course, over here we just lump it all together, right? But there might be two different things. One is you really calculate or really evaluate the contribution from different parties, right? The value of the data. This is probably something you need to kind of work it out first, and then we talk about rewards. But reward, as I mentioned, you can probably go different direction, right? So contribution, I think at the moment we're already start doing something, right? But probably for more specific type of models. But we are trying to see whether we can have more generic kind of a contribution calculation, right? So those are things that we are currently doing a lot of work. I mean, of course, we also need to work with other member of the community, either being the research or maybe academia or maybe industry, right? We're open for that. Yeah. So, and then last but not least is certainly the robust or the reliability of the system, right? Earlier on, I mentioned federated learning in a way is a bit like a double-edged sword, right? On one hand, you don't need to really expose your data to others, right? Let's for the legitimate user, yes, there's the benefits. But for those people with a little bit of a malicious kind of a goal, right? So they may really just go ahead and poison provide some data which has been somehow have a bit of a poison. I mean, basically data poisoning or kind of attack, right? Or maybe even a model poisoning kind of attack. So how do we really kind of make our platform secure against those kind of attacks? I mean, certainly there's something to be be looked into, right? This is certainly something to be looked into. Yeah. So again, this is something that we will certainly need to take into consideration, but maybe slightly more longer term, right? So those are in terms of the roadmap. I mean, we are serious about this one. As I mentioned, we are starting the journey, and certainly not the end of the journey. And next year, when we make the so-called launch next year, it's also not the end of the journey. Certainly, the journey will continue, and we are happy that we can walk the journey together with the community. Right? And on the other hand, as I mentioned, we are also like looking for the more usage or more deployment of our platform as well. Right? So if you have anything you have, feel free to reach out to us and let us know. And this is probably the last slide I have. I just want to quickly talk about the vertical federated learning, because just now I mentioned in our pipeline, next year when we make the launch, federated learning, vertical federated learning is also something that we are going to support, right? So vertical learning in a way is a bit different from the horizontal one. So horizontal one basically is like the data has been split horizontally, right? But in this case, basically for vertical federated learning is the data will be split vertically in a way. Different party, right? They might see the same set of objects, right? But different party will see different attributes or different feature of the same set of user, right? So let's say, for example, let's say party A has feature 1, 2, 3, right? Party B has feature 4, 5, 6, and party C has 7, 8, 9, right? But more or less, they have a big overlap in terms of the objects, right? Let's say, for example, for this one, a quick example would be maybe insurance industry or insurance company trying to build a model to predict whether a policy going to lapse or not, right? So typically, if you just look at the insurance domain data alone, you may not be able to predict lapse behavior very accurately, because lapse sometimes also decided by other factors. Like, let's say, for example, maybe you lose your job, you don't have no income, or maybe you can't really support the policy anymore, right? Maybe you just let it lapse, right? So for that, you might want to look into data from other industries as well, right? For example, banking, right? So that's why you might want to get data from other company or other industry, but they will have a different feature, right? I mean, in this case, maybe insurance, you have the policy information, but for banks, you have the transactional information about that particular customer, right? But the two companies will come together, they will form a better picture of the user, right? Something like we call it like 360-degree view of the user, right? So this is something that we call it a vertical federated learning, and then we're trying to use speed learning in a way to consolidate the two, right? So they try to use it as a kind of a consistent way to support both horizontal and vertical, right? So those are kind of in our plan, right? So that's about it. We leave a kind of a QR code here. Feel free to reach out to us if any suggestions or feedbacks either in terms of feature or in terms of application of the Synergos or federated learning. Do reach out to us, and so more than happy to have a conversation with you. Yep. And I hope I answer your question, Ed. Yeah. If not, I mean, you can certainly just follow up with more questions. Yeah. Thanks.
Hey guys, do you have any questions?
Yeah, I know it's kind of after work hour. Yeah, it's family time. I really appreciate your time here. Yeah.
So one user is asking, Ed, he's mentioning about credit for sharing data.
Yeah.
So if one need more than one credit, like, is it possible to like purchase?
Yeah. So this one, in fact, I touched upon a little bit just now, right? So I mean, yes, we haven't really like quite made up our mind like how are we going to so-called design the reward system, right? Because the reward can probably go different direction, right? It can be a monetary kind of a reward, like okay, you contribute data, you get something in return, right? Which is more direct. Right? That can be one way. But another way, it could also be maybe you reward data, maybe your data quality is higher, right? Then maybe you get a better version of the global model. Because just now, throughout the presentation, we only talk about one global model, right? But there might be a scenario is different people or different party may get a different copy of the global model, right? And then different people based on a different party based on their contribution, they may get a different quality. I mean, a different version of the model with different quality, right? So those are things. I mean, technically it's possible, right? But just that we haven't really quite made up our mind, like so-called business model point of view, like what would be the final one which you're gonna adopt. It could be probably coexist, right? It could be probably coexist. Yeah. So this is a kind of answer to Ed's question. Yeah. But if you feel that it's not really answering your question, feel free again follow up with some other questions. And I saw another question. So for the current reward system, which one do you guys adopt, aggregatory or individual? Okay. Again, it's a very good question. As I mentioned, right, we haven't really, a lot of people interested in this topic. Feel free to have a follow-up question on this. I'm more than happy to hear your suggestions, right? And as I mentioned, we haven't really quite made up our mind, like what would be the final one we're gonna adopt, right? So eventually it could be, maybe we're going to support both, right? But again, maybe it's something like when you set up, you need to probably choose which one you want to adopt, right? At the moment, we haven't really quite made up our mind that what would be the type of a reward system we're going to use. But at the moment, I think because we already start doing something, but our current focus is more on the contribution side, right? Because no matter what kind of reward system you are developing, at the end of the day, what really matters is how do we go about and evaluate the value of your data, right? So this is probably something like sometimes, I mean, of course, we just assume, okay, yeah, you probably set aside a fixed amount of money and then do the rewards. But at the end of the day, how do we really like quantify, okay, how much I gonna reward you based on what? Based on what basis, right? So I think to that extent, it's really based on the quality of your data, right? Because at that moment, I think if you look at fair average, at the moment, I think it's really based on proportional to the volume which different party contributes, right? But I think Mark just now also mentioned about that, right? And then I can just give you a lot of the rubbishes, right? By times. But does it mean that I'm gonna get more rewards? Probably no, right? It's really like it depends on how you really look at that, right? So those are the things we are currently looking into, right? So I mean, we do have some idea in mind, but just that it's a bit like a more specific to certain specific type of model, right? But we are trying to see whether we're able to come out something which is more generic, right? You don't need to, maybe, how to put it? It's like, okay, one kind of a way to evaluate the quality which can be applied to no matter what kind of model you're using, either you're using Bayesian or non-Bayesian, or either you're using deep learning or non-deep learning. We are all our approach. We're hoping that our approach is able to tackle, I mean, to cover all of them. So that was something that we are currently looking into. We haven't really quite started on the reward yet. I mean, we treat like contribution and reward as two different things, right? We know it's probably important, but we probably are doing it step by step. We try to tackle the contribution first, right? How am I going to really evaluate the contribution from different parties, the value of your data, right? But of course, the reward itself is not just rely on the data. It probably also comes with the computational cost as well, right? Because I contribute more, right? Because also, you probably also need to reward me a little bit more on that, right? So, but that will be probably to us, probably the secondary things. I mean, we are at the moment we are really focused on, or not really, I mean, put more kind of a thoughts around how are we go about and quantify the contribution from different parties. Yeah. So that was our thinking behind. Yeah. I hope I answer your. It's a kind of a long, winding answer, but I hope I do answer your question. Bin Chan, yeah. I hope I answer your question. Yeah. Any more questions? Yeah, there seems to be a lot of interest about the rewards, right? I mean, this is also, in fact, this is also our hope, right? Because I think before we really start this, we look around, and yeah, I mean, like those systems, they haven't really like tackled it. I mean, it's certainly not an easy problem to tackle, right? So that's why we also felt this is an important thing. It certainly is an important thing. And then, in fact, in the academia, right, research-wise, there's a lot of activity going around this topic as well. Yeah.
Any more questions? I guess not.
Yeah. So I mean, we leave a QR code here. I mean, maybe you can scan and yeah, I mean, reach out to us. There's another question. Does it require the participant to be online 24/7 since any workers can call for computation? To adopt your framework, does it depends on what kind of a scenario you are talking about. I mean, internally we discuss about that, right? So I mean, for horizontal, maybe you don't really, right? Because I mean, there's a two phase. One is more like a training phase, right? Training, yes, you basically a different party will agree. Okay, let's say assuming two parties will say, okay, let's go together hand in hand and let's go and train the model, right? Of course, then during this period of time before the model training, I mean, the model converges. Certainly, you need to be online and to do that, right? I mean, of course, there might be scenarios which some party might halfway just drop out, right? I mean, like it also happens, right? Then I mean, of course, then you need to kind of in a way need to take into consideration when you're doing the aggregation, right? So I think for Fed average and the Fed prox, you also have a bit of the kind of a provision for that as well, right? But of course, you need to be you need to make sure that a certain percentage of your parties need to be online. But in our case, again, we're more talking about like enterprise kind of setting, right? So maybe the participants usually in a smaller amount, I mean smaller scale, right? So probably we need to agree that okay, different party probably all need to be online during the period of time, right? During the training stage. But then when it comes to the inference, right? When it comes to inference, I think for horizontal, you don't really need all the parties to be online, right? Because the model has been trained, right? As I mentioned, after you kind of finish the model training, and maybe a new party want to, or maybe existing party or new party want to be part of the to use the model, then you just need to join the so-called grid, right? You just need to download, and then in a way the model will be pushed to you, so you can do the local inference. You don't really need other party to be kind of online for you, right? But for vertical, right, I think it might be the case because the other party may be some, because in vertical scenario, no single party will have the complete model, right? Because in a way, it's like different the model has been chopped into different pieces, right? And different people hold different different piece, right? So you really want to do the inference, yes, you might still need to require all different parties to be online 24/7, right? Again, I hope answer your question. For vertical, yes, it might happen to be the case. But this is not just for, I think it's not just for Synergos, right? It's really for federated learning in a way. I mean, if you want to do a vertical federated learning, you probably need to do that. Now, otherwise, in a way, because at the end of the day, when it comes to inference, you still need other parties to give you the value. Okay, maybe just pick example, right? Let's say, assuming we are building logistic regression, right? It's easier to understand. So basically, it's kind of the let's say you have three features, right? So each one going to contribute one feature, right? So basically, each of them will carry a weight for its own kind of a coefficient for its own kind of a feature, right? So now, because no one really like share the data to other party, right? So in order to calculate the prediction, you still need like all the other party to give you the value of their part of their equation, right? Just imagine your original equation is three features, but now you've been chopped into individually like one feature each, right? Then you still need the other party to give you the value of their portion of the equation, right? And then you need to kind of put them together to give you the final outcome, right? So you still need to require the other party to be online to serve you the results, yeah. Right? Okay, there's another question I just missed it. Data is still owned by the partners and in their server, right? If so, we assume OPEX cost of getting data from their server is taken care by the owner themselves. Yep, right. That in fact, in a way, it will tie to your reward system, right? Because in a way, just a bit like in a normal market, there will be kind of a what do you call it, your own cost, right? I mean, the cost you try to bring all your ingredient on the table, right? Yeah, I mean, in this case, the data has become your ingredient. You might spend so much amount to acquire the data. Of course, you're trying to somehow recover your cost, right? Yeah, yes, that will be part of the equation, right? But of course, then as I mentioned earlier on, you need to also calculate from other party, right? They also need to calculate the value of your data to them, right? If you feel that, okay, if they feel that your data is not really valuable for them, even you might spend $1 million to acquire your data, they probably don't want to really, I mean, pay for you, right? Just a simple analogy. So yes, I think the cost would be like kind of a burn by the owner first, but maybe you will try to, when we design the reward system, we need to somehow factor that one in, right? But again, the reward system, we are still in a way of designing it, right? So we haven't really haven't really made up our mind, right? But if you have any suggestion, again, feel free to reach out to us. So more than happy to have a conversation with you. Yep. Any more questions?
I guess not. I think we can close the stream. I think the topic is pretty exciting. I know it's pretty late in the evening for you guys. So thank you very much, Jianshu, Maurice, and Mark, for spending your evening on sharing all the wonderful work that you're doing. Again, a lot of thoughts. I for certainly be in touch of what we can do next. So all I can say, thank you.
I think it's really our honor to be here, and also appreciate your time to be here and to organize this session, and then to the audience as well. I mean, it's really quite late, right? And it's still like stay on to listen to us. It's really appreciate that, and feel free to reach out to us. As I mentioned, I mean, we are just starting the journey, and we are really will be very feel very honored if you can walk the journey together. Yeah.
Mark, just one more thing is, because the videos come in the bottom, so your QR code gets hidden.
Okay.
Do you just want to kind of show the QR code for
sure.
people?
Maybe I move. Let me try to move my QR code to the top. Just give me a second, and then
Sure.
I will. Yeah. I also noticed that. Just give me a second. Let me do the change. Do the change. Let me stop sharing, and then I will make a change. Right. Let me just do that. Right. Okay, let me go into the sharing mode again. Yep. I'm going to the top corner, yeah. Yeah, so yeah, scan the QR code and then feel free to reach out to us, and really appreciate any of the feedbacks or suggestions, either in terms of the feature or in terms of the applications. Right, really more than happy to hear your thoughts. And thanks Ashish. Yeah, thanks Ashish for your. Yeah, it's good that you also get you interested into federated learning. Yeah, I think it's really yeah. We hope, I mean, like as I mentioned earlier, we really hope that we can walk the journey together, right? We're starting a journey, but we shouldn't be the only one in the journey. We should really walk the journey together and do something great things together. Yeah.
All right. I think that will be all. Jianshu has shared the QR code. This video will be available on the same link. So if you have missed any part, or you want to go and look at the QR code, the stream will be available almost instantaneously So feel free to refer back. And thank you once again, Mark, Jianshu, and Maurice for being here with us this evening.
Thank you.
Thanks.
Thank you.
Thanks.